Good morning. We're doing 3.5 and 3.6, which is on the Pythagorean theorem, the distance formula, and the midpoint formula. The Pythagorean theorem states that in any right triangle, the square of the longer side, which is the hypotenuse, is equal to the sum of the square of the other two sides, which are the legs. So the hypotenuse here is C, and it is the one that is always across from the right angle or the 90-degree angle. And A and B are the legs, and they can be interchanged. It doesn't matter which one is A and which one is B. So the Pythagorean theorem is A squared plus B squared equals C squared. The hypotenuse of a right triangle is 9 inches. Okay, since it's the hypotenuse, it's across from the 90-degree angle right there, and we have to make sure that that gets over here for our C. One of the legs is 7 inches. Okay, so it doesn't matter which one you put it at, it's just one of them, okay? Find the length of the other leg. All right, so let me put this in here. I'll have an A squared plus a 7 squared equals 9 squared. So A squared plus 49 equals 81. All right, so we're solving for A. Let's move the 49 out of there. And I'll get an A squared equals 32. Okay, well, I'm solving for A, not A squared, so I need to take the square root of both sides, and I'll get A equals the square root of 32. Now, normally we would use a plus or minus in front of that square root of 32, but since we know it is a distance, a length over here, it can only be positive, okay? So all standard rules apply for simplifying this. You know, we can't have a perfect nth power under there. So if I take that square root of 32 and rewrite it, that is really, what, a 16 times 2? So the square root of 16 is going to give me a 4. The square root of 2, there's nothing I can do with it. So in simplified form, that would be our answer. This would be 4 square root of 2. Or we can approximate it as well. So approximate, use those signs anytime you're going to have to round something. And if I stick that in my calculator, I'm going to get 5.66. All right, so that's the Pythagorean theorem, and we need that Pythagorean theorem to figure out the distance formula. Okay, so the distance formula, I have 2 points, any 2 points. It doesn't matter where they are. And even this one could be 0.2 and this one could be 0.1. Doesn't matter, okay? So if I want to find the distance between those 2 points, I'm going to use the Pythagorean theorem. I'm going to make my right triangle right here, and the address of this point would be x2 and y1, okay? If I wanted to figure out the distance between here, or what that length is, that would be x2 minus x1. And some people are like, what? How did you get that? Well, let's say that this point right here was 5 and this point down here was 1. How would we figure out that distance? We'd say, okay, 5 minus 1 gives me a 4. So we're just doing the same thing here with variables. And these are subscripts and not exponents, okay? So x2 minus x1 is the length here. And if we were to do the y's up here, it'd be y2 minus y1. Okay, so we have our Pythagorean theorem here because we want to figure out what the distance is. So A squared plus B squared equals C squared. All right, A, we're going to go with this one here. So that's going to be x2 minus x1, and we're going to square it. Then we're going to add on our B. This is our B over here. So y2 minus y1, and we're going to square it. And this is going to equal our C. And here is C, but we're calling it D, right? Equals D squared. Okay, so I want D, not D squared. So I'm going to take the square root of both sides here, and I'll get d equals square root of x2 minus x1 squared plus y2 minus y1 squared. And that is our distance formula right there. Okay, so that's an important formula. You guys should know it. Right there. All right, so our problem is find the distance between 3, 5 and 2, 1. So I'm calling this one point 1. It's at 3, 5. My point 2 is at 2, negative 1. So this point 1, this is my my x and my y. Ordered pairs always come in x, y. Okay, ordered pair x and y. And since this is our ordered pair for 2, it's going to be x2, y2. All right, now I'm just taking that information and putting it into the formula here. So here is my square root. My x2 is 2 minus my x1, which is 3, and I'm going to take that and square it, plus, okay, so my y2 is negative 1, minus my y1, which is 5, and then I'm going to square it. So 2 minus 3 gives me a negative 1. I'm going to square it. And that gives me a negative 6. So I'm going to square it. And that's still under the radical. So negative 1 squared gives me a 1. Negative 6 squared gives me a 36. Okay. That gives me a square root of 37. There is nothing I can do with that square root of 37. So that is it, okay, on that one. All right, midpoint formula. Oh, I want to go back to this drawing here again for the midpoint formula. If I wanted to find the midpoint between 2 points, midpoint's the one that'd be right in the middle there. What I would do is I'd add together my x's and divide by 2. It'd give me the average there. That would be for my x's. My y's, I'd add together my y's and divide by 2. That would give me the average. Okay, so here is our midpoint formula right here. Add together your x's, divide by 2. Add together your y's, divide by 2. So I want to find the midpoint between 3, negative 1, which is right here, and 7, 5, which is up here. Okay, so my midpoint should be right here. I measured it out. Okay, so again, my point 1, here is my x1, y1, point 2, so x2, y2. So here's my formula. Let's just plug it in. x1 is 3 plus my x2 is 7, and put that over 2. My y1 is negative 1 plus my y2 is 5, and put that over 2. Okay, so this gives me a 10 over 2. This gives me a 4 over 2. Reduce it down. Remember, fractions, you always have to clean it up. 5, 2 would be my midpoint. Let's take a look at that. 1, 2, 3, 4, 5, 1, 2. It's right there. All right, enjoy. Bye.